Hello guys, in this lesson we are going to be studying the Unit 7 exam review. Let's get started. Alright, so what's the gram formula mass of ammonium phosphate? We can just start that out with a pretty simple inventory with masses and quantities. So these are the masses of the selected elements. I'm going to add quantities now. So I did that and I'm multiplying it by their quantities to get the contributions. And finally I'm going to sum them all. And I got 149 grams per mole, which is why I'm going to select choice 3 as my answer. Number 2, the total number of moles represented by 20 grams of calcium carbonate. On the back page of your reference table, on table T, it tells you that the number of moles is equal to the given mass over the gram formula mass. So let's do just that. Let's put the given mass over the gram formula mass. So I went ahead and put the number of moles as the given mass over blank. So I was able to find that we have 40 grams per mole of the calcium, 12 grams per mole of the carbon, and 48 grams per mole of the oxygen for a sum of 100 grams per mole. So you can put that in the denominator now. And that leads you to the answer that we must have 0.2 moles of calcium carbonate. So for the next question, what's the total mass of oxygen in 1 mole of aluminum chromate? So we have 1 mole of aluminum chromate. There is an invisible 1 here, so the 1 mole they're talking about is just the mole of aluminum chromate that we see. But they want to know the total mass of oxygen here. And I can see that we have, let's see, 3 times 4, or 12 moles of oxygen. And I also know that every mole of oxygen has a mass of 16 grams per mole. I wrote it like this because my intention is for the moles of oxygen to cancel out with the moles down here. And then I just need to multiply the 12 by the 16 to get 192 grams. So I believe the best answer would be choice 1. Alright, what's the total mass in grams of 0.75 moles of sulfur dioxide? So if we're starting with 0.75 moles of sulfur dioxide, and we need to multiply it by a conversion factor, then that conversion factor should have moles in the denominator and grams in the top, so that we can get the unit that we want, grams, while also canceling moles. So we need a gram formula mass for sulfur dioxide. I was able to get the answer 64 grams per mole, so that means that we can write it in to our conversion factor here, 64 grams over 1 mole. And then I just need to cancel these 2 moles and multiply the 0.75 times the 64. And I'm getting 48 grams as my answer. So choice 4, final answer. Okay, a substance has an empirical formula of CH2 and a molecular mass of 56 grams per mole. We want to know the molecular formula for this compound. And we need to start by finding the mass of the empirical formula. So I was able to find that the empirical formula is going to have a mass of 14 grams per mole, but the molecule has a mass of 56 grams per mole. So let's do a ratio. I was able to find that 56 divided by 14, which is the molecule's mass over the empirical unit's mass, was 4. That means that the molecule right here is 4 times larger than the empirical subunit. Now if that's true, then the empirical subunit of CH2 is only 1/4 of the actual molecule. So I'm going to multiply all of these subscripts here times 4. So the invisible 1 gets multiplied by a 4 and we get C4, and the 2 gets multiplied by a 4 and we get H8. So the best answer for this one is going to be C4H8. So what's the percent composition by mass of nitrogen in NH4NO3, and the gram formula mass is 80 grams per mole. So I checked table T for a formula that would be helpful to me, and I found gram formula mass, I found percent composition, and it said mass of part over mass of whole times 100. So the mass of the part is going to be the mass of all of the nitrogens, which in this case is going to be 1 mole and 2 moles of nitrogen. And I know that nitrogen is 14 grams per mole, so I'll multiply that by 2 to get 28 grams. And that's the mass of the part, but I need to divide this by the mass of the whole. They said that the whole thing was 80 grams per mole, so I'll just put an 80 down here, and then I'll multiply that by 100, and my final answer is 35%. So best answer is choice 2. Number 7, the percentage by mass of bromine in the compound AlBr3. So we'll use the same tactic here. Table T says that we need to use the mass of the part over the mass of the whole times 100. The mass of the part in this case is going to be the mass of bromine, which is, after a quick calculation for the formula mass, I found that the mass of the bromine is 240. So the mass of the part is 240. The mass of the whole is 267. And I need to divide those and then multiply by 100. And my final answer is almost 90%. So choice 4 is my best answer. All right, so let's try this next one. Given the balanced equation, which states that 2 moles of, butane are combusting in the presence of 13 moles of oxygen to produce 8 moles of carbon dioxide and 10 moles of water. We want to know the total number of moles of oxygen, so we're focusing here, that must react completely with 5 moles of butane. Now currently we have 2 moles of butane combining with 13 moles of oxygen, but they want to know how much oxygen is required to combust with 5 moles of butane. So let's set up a proportion using the fixed ratios of this equation. So we have our 2 moles of butane and our 13 moles of oxygen, but we're setting up our proportion, and they're suggesting that we need to react with 5 moles of butane. So instead of 2 moles, we're going to have 5, and for the oxygen, we don't know yet, which means that our proportion reads 5 over 2 is x over 13. So this is telling me that we have 2x is equal to 5 times 13, which is 65. And that also means that x is going to be 65 divided by 2, which is 32.5 moles. Best answer then is choice 4, 32.5. All right, so let's do number 9. What's the gram formula mass of copper sulfate pentahydrate? We need to include the water when we do this gram formula mass because it doesn't say not to. So we'll include that water. I'm going to set up an inventory with masses multiplied by quantities. Things I'll point out before going any further was that for copper, because it was right in the middle between 63 and 64, I chose not to round it beyond the 0.5. And for H2O, I know that its mass is 18 because oxygen is 16 and hydrogens are 1 each, so 2 times 1 is 2 plus 16 is 18. I multiplied through to get the mass contributions, and I'm going to sum them for my gram formula mass. And I got 249.5 grams per mole, which means that my best answer is 250, or choice 4. And for number 10, we're asked what's the gram formula mass of magnesium chlorate. Let's use an identical approach. So I chose not to round magnesium and chlorine past their tenths place, and after I add all of those up, I get 191.3 grams per mole, so of course my best answer is choice 4, 191. For number 11, let's use the same strategy. What's the gram formula mass of lithium sulfate? So I went ahead and recorded my data and multiplied through, And I'll need to sum these up to get my gram formula mass, and I'm getting 110 grams per mole, which of course means that my best answer is choice 3. All right, next up, given the reaction, 6 moles of carbon dioxide in the presence of 6 moles of water, producing a mole of glucose and 6 moles of oxygen. I don't know if you guys remember this one, but this is the equation that represents photosynthesis. But all we really need to do here is create a proportion. So we need the total number of moles of water needed to make 2.5 moles of glucose. And we know that ordinarily we're going to use 6 moles of water, but we're going to figure out how much we would need if we use 2.5 moles of glucose, or we produce 2.5 moles of glucose instead of our typical 1. So the proportion is x over 6 is 2.5 over 1, or 1x is 15 moles of water, which is why my best answer is choice 4. Okay, given the reaction, which states that lead chloride and sodium chromate can make lead chromate and sodium chloride, we're asked to determine the total number of moles of sodium chloride, which is this guy right here, when 2 moles of sodium chromate, or that guy right there, react completely. Now, right now, our ratio between sodium chromate and sodium chloride is 1 to 2. But the thing that we're being proposed to do is to figure out the total number of moles of sodium chloride, so that's X, formed when 2 moles of sodium chromate are completely reacted, so there's a 2 there. And that means our ratio is going to be 2 over 1 is equal to x over 2. And that means that 1x is 4 moles. So my best answer is choice 4, 4 moles. Okay, let's do the next one. So given the equation wherein 2 moles of ethine is combusting in the presence of 5 moles of oxygen while producing 4 moles of carbon dioxide and 2 moles of water, we are being asked how many moles of oxygen are required to react completely with a mole of ethine. Well, I do know that 2 moles of ethine will react completely with 5 moles of oxygen. But we want to know how many moles of oxygen, or X, is required to react completely with 1 mole of ethine. So we're changing the scenario from 2 moles of ethine to 1 mole of ethine. So our proportion becomes 1 over 2 is x over 5, or 2x is 5, and x is 2.5 moles. So that's why my best answer is choice 1. And lastly, the percent composition by mass of magnesium and magnesium bromide, and they give me the gram formula mass, which is awesome. So we just need to know the equation from table T, which states that the mass of the part over the mass of the whole times 100 is percent composition. So the mass of the part in this case is going to be the mass of the magnesium, which is 24 grams per mole. And the mass of the whole is the gram formula mass, which in this case is 184 grams per mole. So ordinarily we would need to get our final answer for that by solving it, but it looks like they just want the setup here. So my best answer choice is choice 1, 24 over 184 times 100.